The electric field in a rectangular waveguide of inner dimensions A cross B is given by E is equal to omega mu by h square pi by a h naught sin 2 pi by a x whole square sin omega t minus beta z ay cap where h naught is a constant. And A comma B are dimensions along the x-axis and the y-axis respectively. The mode of propagation in the waveguide is option A TE20, option B TM11, option C TM20, option D TE10. So this is another kind of problem. The solution to this problem is, suppose here if you observe, it is given electric field. It is given electric field sin omega t minus beta z. Sin omega t minus beta z. That is, the wave is propagating in z direction. The wave is propagating in, suppose this is z direction, and the electric field E is perpendicular to the z direction. E is given. Here they are asking either TE or TM. The only possibility is TE propagation or TM propagation. We know that TE propagation means Ez equal to 0, H Ez is not equal to 0. Suppose we are assuming the wave is propagating in z direction. TM means Ez is not equal to 0, Hz is equal to 0. That is, Ez field exists here and here Hz field exists. If you observe here, it is given E field. It is given E field, which is perpendicular to the propagation direction. E field. This is 90 degrees. So definitely this belongs to a TM mode propagation wave. TM mode propagation. Or what is the TM general equation? TM general equation is, it has some E given by some E naught into sin m pi by a x into sin n pi by b y, and suppose e power minus gamma z. This is because of propagation. So if you compare the given equation with this standard equation, here also it has a sine terms. So this is sin 2 pi by ax whole square, total whole square. So sine terms it has. So obviously we can say that TM mode propagation. The wave equation given is a TM mode propagation. So directly we can eliminate option A and option D. One more thing here, the only possibility is a TM mode propagation. So here TM11 and TM20. Two options are there. Then what is the given thing? If you compare this, E is equal to some total E naught. The entire first this part I am writing as a E naught is equal to sine square, sine 2 pi by AX into sine again 2 pi by AX. I am writing like this into sine omega t minus beta z. So this propagation, this is also propagation direction, this gives propagation. That is, here if you compare with this original standard equations, sine m pi by x, so here m pi by x, 2 pi by x. So if you compare, m is equal to 2, m is equal to 2. But here 2 pi by ax again, but here it is n pi by v, so you cannot compare this. So m is equal to 2, so n is equal to, we have to consider 0, so TM20, TM20, which is a wrong option, because we know that for TM20 either this combination, that is both 0 0 or 0n or m0, these combinations are not valid. Not valid, because for these combinations all components become 0. So what is the lowest possible mode? TM11 is the lowest possible mode. Lowest possible mode. So TM20 is not the answer. So obviously TM11 is the option. TM11 is the option. So here the thing is, the equation is like this. This is not a sine 2 pi by ax, it is a by 2 sine pi x a by 2, similarly sin pi a by 2, a by 2. So if you, even though if you compare with the standard equation, this m is equal to 1, we have to consider this as n is equal to 1 only, n is equal to 1 only, because don't consider n is equal to 0, don't consider n is equal to 0, because 0 combination is not possible. So obviously the answer is TM11. So this is a very interesting problem. Next problem is, which one of the following represents the electric field lines for the TE02 mode in the cross section of a hollow rectangular metallic waveguide. Option A is this is option A. Option B is this is x-axis, this is y-axis. So here they are asking front view. So how the front view electric field lines looks. So this is option B. So this is option C. This is X. This is Y. So the lines are like this. So this is in downward direction. Few lines are upward, few lines are down. Option D is this is x-axis, y-axis. This is opposite direction, right? So these are the options given. So here they are asking which one of the following represents electric field lines for the TE02 mode in the cross section of a hollow rectangular metallic waveguide. So this is another kind of problem which we will discuss here. So the solution to this problem is, here we know that we will discuss the general concept so that which is helpful to solving this type of problems particularly. So here we have TE-MN mode possible and similarly TM-MN mode possible. First of all we will discuss TE-MN. What is M? M is number of half cycles along x-axis. Similarly, N is number of half cycles along y-axis. This is x, this is y-axis. So here I am giving a simple way how we can remember easily front view is like this. Suppose I am starting with TE10. So here M is equal to 1, N is equal to 0. M is equal to 1, N is equal to 0. So number of half cycles along x-axis is 1, number of half cycles along y-axis is 0. So the representation is like this. Suppose this is x-axis, this is y-axis. So along x-axis 1 half cycle. So here the front view looks like this. This is a half cycle. So TE10. So all only in one direction. Similarly, suppose TE20. That is here M is equal to 2, N is equal to 0. That is the number of half cycles along x-axis is 2, number of half cycles along y-axis is 0. So the representation is like this. So this is x-axis, so this is y-axis. So number of half cycles along x is 1, x is 2. So the representation is like this. This is one. Another one like this. Another one is like this. So I am representing it in opposite direction. So this representation is like opposite direction. That is like this. So to represent this, I am representing in a half direction like this. So this is another half cycle which is in opposite direction to the original one. So this is actually. So this is another half cycle. So total how many half cycles along x-axis? 2. Along x-axis is 2. But along y-axis there is no change at all. All are perpendicular lines along x-axis only. So there is no change along y-axis. So along y-axis it is 0. Suppose I want TE01. So TE01 means what? M is equal to 0, N is equal to 1. Number of half cycles along x-axis is 0. Number of half cycles along y-axis is equal to 1. That is, the variation is along only along y-axis. So this is x-axis. So this is y-axis. So the variation is along y-axis. So half cycle, only one half cycle. So to represent that, I am representing like this. Only one half cycle. Like this. This is the half cycle representation along the y-axis. Of course, this is not the exact method of drawing. Just for how to remember easily is front view. How to remember the front view easily? I am showing like this. TE01. Similarly, suppose if you go for TE10, 10 already we discussed. 02. That is m is equal to 0, n is equal to 2. N is equal to 2. Then how to represent this? This is the number of half cycles along x-axis is 0. Number of half cycles along y-axis is equal to 2. So this is x-axis. This is y-axis. So there are two changes along y-axis. So I am representing this is one change. Another change is actually this is like this. So another change is opposite to the previous one. So like this. If you represent completely, you can also represent this full lines. So one is this direction, one is this direction. This is TE02. So along x-axis there is no change. Along x-axis there is no change. That's why m is equal to 0 here. So this representation is TE02. So this is okay. Now suppose if I want to represent TE11, that is m is equal to 1, n is equal to 1. That is number of half cycles along x-axis is 1, number of half cycles along y-axis is 1. So the pattern looks like this. So this is one of the easy way to represent it or to draw. This is x-axis, this is y-axis. Number of half cycles along x-axis is 1, number of half cycles along y-axis is also 1. So I can represent like this. This is the representation of TE11. TE11. That is, if you look at this, this is 1/4 line, 1/4 cycle. This is another 1/4 cycle. So along x-axis totally 1/2, totally half. So m is equal to 1. Similarly, along y-axis this is 1/4. This is another 1/4. So this is total half. So along y-axis this is half. So of course even this is also half. So along y-axis total we have 1/2 cycle. Along y-axis total we have 1/2 cycle. So along x-axis only 1/2 cycle. Don't consider this this total as 1 and this another half. The entire thing is only half cycle. Along x-axis it represents only half cycle. So this is a way of representing TE11. Suppose if you want to represent TE21 mode, so it is very simple now. This is x-axis, this is y-axis. Along x-axis, how many? M is equal to 2, n is equal to 1. Therefore, number of half cycles along x-axis is 2 and along y-axis is 1. So, I am representing like this. This is half. So, first of all, represent along y-axis. So, this is another half. So total along y-axis is 1. Here 1/2 cycle. 1/2 cycle. Here I want 2, but here only 1/2 cycle is completed. So another half cycle I am representing like this. The lines are like this. So similarly here also like this. So this is the front view looks like for a TE21. So this is 1/2 cycle. This is these two combinedly gives another 1. So 1 plus 1. Total 2 half cycles along x-axis. So TE21 mode. So in this way you can represent very easily. Suppose if you want to finally, suppose TE32. If I want to represent TE32 mode, the electric field lines, how we can represent is, so here m is equal to 3, n is equal to 2. So this is along x-axis, this is along x-axis, this is along y-axis. So total number of half cycles along x-axis 3. So start from the corners. So this is 1/4, this is another 1/4. So total 1 half cycle. This is another half cycle 2. This is another half cycle 3. So total 1, 1, 1/4, 1. Total 3 half cycles along x-axis. So similarly y-axis I want 2. So this is already 1/4. So this is another 1/4. So total half cycle is 1. Another 1 here. So total number of half cycles along y-axis is 2. Along x-axis is 3. So similarly this also here, opposite direction. So like this we can represent easily the electric field lines on the walls, TE32 mode. So like this we can draw for any number of any general M and N values TE lines. So remember, this is just a way to remember by looking the graph or by looking the picture. So what is this mode, we can say easily. So don't think that this is the exact way to draw the lines. Suppose this is the entire thing is for TE. Suppose if I want TM modes, for TM modes how the front view looks like. The front view is in terms of circles. Suppose TM, what is the lowest possible mode? Lowest possible mode is TM11. TM11. That is, the front view looks like this. Along x-axis 1 circle, along y-axis 1 circle. That is the thing to draw easily. So the view looks like this. Only this is the circle along x-axis, along y-axis. So TM11. Suppose if you want to represent TM21. So this is along x. This is entire circle. These are the entire circles. Suppose TM21 if you want to represent along x-axis 2, along y-axis is 1. So this is like this. So along x-axis 2, along y-axis only 1. Suppose if you want to write TM22. Along x-axis 2, along y-axis 2. Like this. Like this you can represent the magnetic field lines. Thank you. Of course, this is a more general view to remember, and some field lines between these two coupling. So I am not drawing those things. So this is a way to easy way to keep in mind, or easy way to remember what are the field lines looks like. So the problem what we are discussing is now we can easily say. So what is the answer for the problem we started? The problem is what is the field lines for TE02. So along x-axis it is 0, along y-axis they are asking for TE02. So along y-axis is it 2. So which one is correct? So clearly option D is right. Option D is right. So for our problem option D is correct. So This is another kind of problem which is very interesting.